Since we have finished chapter 7 before spring break, now after we come back, we are going to review the whole chapter 7 and prepare for the next midterm, test 792. This exam only covers chapter 7. Overall speaking, chapter 7 is a pretty challenging chapter. It has a lot of topics, and we have to know how to do the factorization first, which is covered by chapter 6, and then we can move on to do the problem in chapter 7. So again, if you need help on the factoring or how to work on the rational expressions, please feel free to contact me or contact any tutors and try to fix all the problems you have and then prepare for the test. Okay, so what we see now is a practice test. The real test is on my open math. There will be 20 problems on the real test, or on the practice test. So the format are very, very similar. The only difference will be what we have here. All those are multiple choices problem, but on my open math, you might have to fill out the space, and only a few of them are multiple choice. But the fundamental things are the same. We have to solve the problem by ourselves first. Then we either look for the answer listed here as multiple choice, or we just type the answer into the space. So what I'm going to do today, I'm going to lead you go through the 20 problems that we will see on the test. The problems on the real test apparently will not be identical, but I guarantee they are all same types of problem. So let's get started now. The first two problems are about simplification of rational expressions. When we have one rational expression, we want to simplify it. The general rule is factor the numerator and denominator respectively, and then cancel the common factors. That's it. See, look at what we have here. When we look at the numerator, it is factored already. So I leave this at the original form, x plus 3 squared. The denominator is a binomial in the form of squares minus squares. 9 is 3 squares. So therefore, we can factor it as sum of the two bases times difference of the two bases. So x plus 3 times x minus 3. So step 1, factor the numerator and denominator respectively, if possible. Then what do? Cancel the common factor. Compare. Use our eyes. Do I see anything in common? I see x plus 3 on the bottom. I see x plus 3 squared on the top. The squared means what? Squared means I have 2x plus 3 multiplying together. So then when I cancel 1, there is only 1 left. Rewrite 8, that will be x plus 3 over x minus 3. And when we look at the answer here, B is the right answer. All right, so this is the first one. Second problem, same thing. Simplify the rational expression. Factor. Whenever we do the factor, what do we do first? Check GCF. Do we see any GCF? On the numerator, I see 5, I see 10. I know 5 is a common factor. So 5 times what? The leftover goes to the parentheses. 5y divided by 5, we have y left. And 10 divided by 5, we have 2. So 5 times y plus 2. Over what? Over 5. You don't have to factor 5. Then what do? Cancel the common factor. 5 cancel each other. What is left on the top? Y plus 2. And what is left on the bottom? There is nothing left here. It means we have 1. So everything divided by 1 equals itself. The final answer will be just y plus 2. Okay, so the first two problems on the real test are also the same type. Simplify the rational expression. What do? factor the numerator and denominator respectively, then cancel the common factors. That's it. Number 3 and 4, those two problems, we are going to work on the two multiplication problem. Multiply and then simplify. So when we have two rational expressions and they're multiplying each other, what do? Step 1, draw a long bar. And then put the numerator together. The numerator 1, 3a plus 3 times numerator 2, a squared minus 12a plus 36. Over what? Over the denominator times denominator, a minus 6 times a squared plus 2a plus 1. Okay, so there is no technique here. Just draw a long bar. Put the numerator together. Put the denominators together. Just remember one thing. If we have a polynomial as one numerator or denominator, make sure they are enclosed by a parenthesis. So keep the parenthesis there. And then what do we do next? Now we go back to the first type. This is one rational expression now. How do we simplify it? Factor each one, each parenthesis, if it is possible. Some parentheses, some polynomials in the parentheses are not factorable, then leave them there. Okay, so then I will just take my time and to check each individual parenthesis. 3a plus 3, can I factor this? Yes, I can. 3 is a common factor, and then I have a plus 1 left. Times what? When we have the second parenthesis, what do we see? This is a leading coefficient being 1, the trinomial. If it is factorable, then we need two numbers. The two numbers, their product is 36, their sum is negative 12. What are the two numbers? 6 times 6, that's 36. 6 plus 6, that's 12. If the sum is negative 12, then both of them should be negative. So then I have a minus 6 times a minus 6. If you want, you can also write this as a minus 6 squared. Move on to the bottom. A minus 6. This is a prime polynomial, not factorable. Then when I have the second parenthesis on the denominator, I notice, okay, leading coefficient is 1. I need two numbers. Product is 1, sum is 2. What are the two numbers? 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. So I have a plus 1 times a plus 1. Okay, when we get this step here, use the fingers and eyes. So do we see anything in common? I see a plus 1, a plus 1. Those two cancel each other. Okay, make sure you cannot cancel this a plus 1. One factor can only cancel another one factor. This one cannot cancel both of them. Do I see anything else in common? I see a minus 6, a minus 6. Okay, there is no more common factors. Then write down the leftover here. What is left on the top? 3 and a minus 6. What do we see in the bottom? A plus 1. Okay, that's it. Do we have to carry out this multiplication? The answer is no. Leave this as the final answer. Okay, then when we go here, check the answer. I see D is right answer. It does not matter. As long as we know how to work on this, on a real test, you might have to type the final answer on the computer. Okay, so this is a multiplication problem. One more. Okay, same thing. When we have the multiplication, always draw a long bar. Put the two numerators together, 3w plus 3 times w minus 1. What is on the bottom? W minus 1 times w plus 1. Then what do? Check each parenthesis. See, can I factor any one of them? The first one, 3 common factor. So 3 is factored out. What do we have left? W plus 1. And w minus 1 is a prime polynomial. And on the bottom here, neither one is factorable. Leave them here. Now, The easiest part is what? Do the cancellation. I see W plus 1, W plus 1. Those two are identical. They cancel each other. I see W minus 1, W minus 1. Those two cancel each other. What is left? 3. Where 3 is on the top. So then you just write down 3 here. If, I'll say if 3 is on the bottom of the bar, then you cannot just write 3 here. It's supposed to be 1/3. So you cannot change the location. 3 is on the top. There is nothing left on the bottom. It means there is 1 left on the bottom. But again, 3 over 1 can be simplified. We'll just write down the 3 only. So 3, final answer. Now let's go back to the first 4 problems. We have the simplification problem, and then we have 2 multiplication problem. Think of what we might see the next. Okay, division. So we have done multiplication. Now we will be given some division problems. So number 5 and 6. The problems are given like divide and then simplify. Okay, to do divide, the division problem, we just need to do one more step. So we don't do the direct division, and we just need to convert the division into multiplication. And see what we have here. I have first rational expression, always remain the same. You don't do anything else. Copy 8. When we see division divided by, convert this to multiply. And of course, we can use cross or dot. Okay, if you use cross, it will be very similar to the X. So just avoid the confusion. I put a dot here. Multiply, division turns into multiplication. Then multiply by what? Flip the divisor. Okay, so we're going to flip it over. X minus 9 goes to the top. And 6x plus 54. It's flipped to the bottom here. So turn the division into multiplication. Now we go back to what we just did. How do we multiply? Draw a long bar, put the numerators together. Okay, so that should be, you can see here, x squared minus 81 times what? Times x minus 9. And x times parentheses 6x plus 54. Okay, this step, there is no technique. Just put the numerators together, put all the denominators together. Then factor. Okay, we'll factor each parenthesis if it is possible. First one, squares minus squares. 81 equals 9 squared. So we'll factor it as x plus 9 times x minus 9. And then the second one is this as x minus 9. And on the bottom, we have x times what? 6x plus 54. 6 and 54, they have a common factor 6. So factor 6 out, I have x left plus 9. Okay, now let's just do the comparison. Do we see anything in common? Anything identical? I see x plus 9, x plus 9. Anything else? No more. Okay, just remember, each parenthesis is 1 unit here. You cannot see there is one x, there is one. Can those two cancel each other? The answer is no, because this x belongs to this parenthesis. It cannot be factored, just partially. All right, so that's all we can do. Write down the leftover. What is on the top? I have x minus 9 times another x minus 9. I can write this as x minus 9 squared. What is on the bottom? Okay, when we have a number and a variable, a letter, when they're multiplying, we prefer to write the number in front of the variable. So x times 6, we'll write this as 6x. 6x means 6 times x, commutative law. In the multiplication, you can switch the order. Final answer here. And when we go to left here, we can see the B is right answer. So B is the right answer here. Okay, so one more practice. Division, divide and simplify. What do? Turn the division into multiplication by flipping the divisor. So x plus 1 over x times, flip this over, 3x squared over 2x plus 2. Then draw a long bar. Okay, and some students say, Professor, can I skip this step? Yeah, if you want. Okay, I can do this. So connect those two bars and then put the parentheses around each polynomial. So if you want, you can do this as well. Okay, and then we are going to factor now. Can we factor x plus 1? No, we cannot. Can we factor 3x squared? No, this is factored already. We have x here times the last parenthesis, 2x plus 2. Can we factor this one? The answer is yes. We can factor 2 out, and we have x plus 1 left in the parentheses. Now, do the comparison. I see x plus 1, I see x plus 1. Those two cancel each other. I see 3, I see 2. No, they cannot cancel each other. I see x squared. So one of the x can be canceled. So x squared turn into x. So I cross the square away. And rewrite this. What is on the top? 3x. What is on the bottom? 2. Okay, there is no more else left, just the number 2, 3x over 2. So look at, this is the final answer. Okay, so now so far we have 2 simplification problems, we have 2 multiplication problems, we have 2 division problems. Guess what's going to happen next? Addition and subtraction. So number 7, we'll see add and simplify. Addition problem. When we do the addition, remember, we can only add 2 fractions or 2 rational expressions when they have the same denominator. So when we do the addition or subtraction, they act the same. When they have the same denominators, then we are going to keep the denominator, keep the common denominator. They either add or subtract the numerators. Finally, we simplify. If they do not have the same denominator, what should we do? We have to make them to be the same. How? Look for their least common multiple. Turn all the denominator into the least common denominator. So the least common denominator, LCD, is just the LCM, least common multiple of all denominators. Okay, so now let's go to this part. Compare. Do we see the same denominators? Apparently they are not. So to do this one here, and well, add once. So first, let's try to factor each denominator. So first one, 5x over what? Over 3x plus 9. Can I factor this? The answer is yes. 3 is a common factor. So 3 times x plus 3. And plus the second rational expression, 3x is on the top. What is on the bottom? 2x plus 6. Can we factor it? 2 is GCF, and I have x plus 3. Okay, so leave this here. Now we go to the scrap paper and write down the 2 denominators. The first one is 3 times x plus 3. The second one is 2 times x plus 3. The 2 denominators. I want to look for what? Their least common multiple, which will be the least common denominator. Okay, and how can I look for their least common multiple? Since they have been factored already, I did factorization already. The only thing I need to do is just write down the least common multiple as a product of all factors with the maximum times they appear in each factorization. Okay, this is a very long sentence here. It tells us, okay, I'm ready to write down the LCD or LCM. I will use every factor. So just go through every factor here. The first one is 3. Do I see 3? Okay, I see 3 once here. Do I see any 3? in the second denominator? Okay, no, don't count these three. X plus 3 is one factor. We'll use every factor. These three here and these three here, they are not factors. They belong to the factor x plus 3. Okay, you cannot count these three here. So 3 appears once, appears 0 times. So the maximum time is once. I see 3 once. And then times, go through the second factor I see is x plus 3. So x plus 3 once, x plus 3 once, once. The maximum time is still once. I'm not asking the total. I'm doing the comparison. One time and one time, which appears more? They appears in the same frequency. They appear with the same amount of times, just once. So I will use x plus 3 once only. Continue. So move on to second denominator. I see 2. 2 is new factor. How many times does 2 appear here? 0. How many times does 2 appear in the second one? Once. So once is the maximum time. So times 2. And then we move on. I see the factor x plus 3. This factor is not new because I have used this already. So just ignore it. We'll use every factor. And I have used every single factor. That's it. Then put them together. 3 times 2, that's 6, equal 6 times x plus 3. This will be my least common denominator. Then we are ready. Okay, go back here. I'm going to compare. How can I turn 3 times x plus 3 into the least common multiple? 6 times x plus 3. What do I do? I'll see. I have to multiply this denominator. So if you want this number by 2, so this one times 2. Whatever we do to the denominator, do the same thing to the top. So the numerator should multiply by 2 as well. So I used a different color pen to label what I did. I turned the original denominator into the least common multiple because 2 times 3 will be 6. X plus 3 still x plus 6. Then do the same thing to the second rational expression. How can I turn this into that one? I need to multiply by 3. So this one times 3, this one times 3 as well. So whatever, remember, we cannot just change the denominator. We should change the numerator as well to make sure we are not changing the problem. We just make them into a new looking. Okay, so everything that we have done to the denominator, do the same thing to the numerator, same thing to the numerator. Then I'm ready. Okay, so those two denominators, now they're both 6 times x plus 3 now, but the numerator, 2 times 5x, that turns into 10x, plus 6 times x plus 3. Again, the numerator turns into 9x. When we get this step here, things are easy. Why? Because those two rational expressions, they have the same denominator. Then to add those two, we are going to keep the common denominator. Okay, we are not multiply them. So some students say, can I just, this one and this one, can I just times 6x plus 3 again? No, keep the common denominator. Then add the two numerators, 10x plus 9x. What do we do next? Work on the numerator. Simplify 10x plus 9x. That's 19x. 19x over what? Over 6 times x plus 3. Final answer here. And then go back here. Do I see the answers? Yep. See B. 19x over 6 times x plus 3. Final answer. And starting from number 7, okay, the addition problem is more difficult than the multiplication and division. All right, it takes a lot of time. First, we have to factor the denominators, and then look for their least common multiple, and then turn the rational expression into a new looking. Make sure they have the same denominator. Finally, we add or subtract later. Okay, and very last step, we have to double check. Can we continue to simplify this rational expression? For this specific problem, we cannot. So this will be the final answer. All right, so let's move on to the next one. Add and simplify. When we are given those two rational expressions, we see what they do not have the same denominator. And are we able to factor each one of them? The answer is no. So now we are going to move on to our scrap paper here. I write down the two denominators. The first one is 5 plus 3x. Because this one cannot be factored, I put them into one parenthesis. The second denominator is 5 minus 3x. It is not factorable either. So for those two factors, I want to write down their least common multiple. Okay, this one is easy. This factor appears once, 0 times, so in the least common multiple, it will appear once. And then the second factor is 5 minus 3x. Same thing here, 0 times on the top, 1 time on the bottom. So in the LCD, it will appear as 1 time. Actually, their product will be their LCD. So this is LCD now. Having this in our mind here, I'm going to go back here. I want to turn the old denominator into the least common denominator. Okay, what do I do? Equals. Write down the first one, 3, 5 plus 3x. So compare this old one with the LCD. What is missing here? We are missing 5 minus 3x. So then what we do, we have to multiply by 5 minus 3x, parentheses. Whatever we do to the denominator, do the same thing to the numerator. Also multiply by 5 minus 3x. This is what I just did to the first rational expression. This addition here, add. Then copy the second rational expression, 5 minus 3x. And compare this one with LCD. What is missing here? We are missing 5 plus 3x. Then whatever we do to the denominator, do the same thing to the numerator, 5 plus 3x as well. Okay, so for this addition here, look at it. They have the same denominator. Don't worry about the order. For the multiplication, we have the commutative law. The order of the factors does not matter. So those two have the same denominator. When we're adding them, what do? Just keep the common denominator. 5 minus 3x times 5 plus 3x. Then add the two numerators, 3 times 5 minus 3x plus 4 times 5 plus 3x. So I'm going to add this is the first numerator plus the second numerator. We cannot leave the answer here because the numerator apparently can be simplified. How can we simplify this polynomial? We have to remove the parentheses and then combine like terms. So now take your time, be patient. The denominator remains the same, 5 minus 3x times 5 plus 3x. The numerators, distributive law, 15 minus 9x plus 20 plus 12x. So distributive law, don't forget, multiply everything before the parentheses. Then combine like terms, 15 plus 20, that is 35. And the negative 9x plus 12x will get 3x. 12 minus 9, that's 3. Over what? Over parentheses, 5 minus 3x times 5 plus 3x. Okay, let's see. Will this be the final answer? Can we do anything more to simplify this? The answer is no, because the numerator 35 plus 3x is not factorable, and apparently there is nothing in common. So that will be the final answer. Okay, so those two problems, the addition problems, apparently will take more time than the problem we saw before. Be patient. 7 and 8. Okay, and now the next two, 9 and 10, will be the subtraction problem. Okay, so same thing. When we do the subtraction here, we have to double check. Do we have the same denominators or not? For this problem, we are lucky. When we see this problem, we see both of them. They are x minus 1. So that means we are ready to subtract now. What do we do? Just write down the common denominator and then use numerator 1 minus the subtracted minus numerator 2. So I have 8x squared minus 8x. So for the two rational expressions, when they have the same denominators, we are going to keep the common denominator, then subtract the numerators. This is the subtraction problem. What we got here, we have to ask ourselves, can we stop here? Are we able to continue to simplify this rational expression? The answer is yes. Why? Because we could factor the numerators. 8x squared minus 8x, they have a GCF 8x. So now we actually go back to the problem 1 and 2. Given one rational expression, simplify it. How? Factor the numerator and denominator respectively. For the numerator, I can factor it as 8x times x minus 1 over what? Over x minus 1. Then compare. They have the common factor x minus 1. The final answer will be just 8x. And this 8x is on the top. Over, nothing left on the bottom means we have 1 here. Everything divided by 1 equals itself. Final answer. So look at what we see here. A is the right answer. Okay, subtraction and addition, they are actually very, very similar. And the next one. So this one, we have rational expression. They do not have the same denominators, but both of the denominators are monomial. They're not polynomial. So same thing here, because those two monomials, those two denominators are not the same. We are going to make them into the same denominator. How? We have to know what their least common multiple is first. So go to the scrap paper here, write down the two denominators. 15x. Okay, we know 15 can be factored. So factor both of the denominator. 15 equals 3 times 5. And then x is x. So 15x equals this. 21x squared equals 3 times 7 times x squared. So factor, even though there's monomial, but the coefficient part can be factored. So factor the denominators respectively. Now we are ready to write down their least common multiple. The least common multiple equals what? Equals the product of every single factor with their maximum times to appear in each factorization. So 3 appears, so else equals what? Equals 3 appear once here, once here. So once is the maximum time. The second factor I see is 5. 5 appears once here, 0 time here. The maximum time is still once. I see x here, I see x squared. So for the same variable, we'll use the maximum exponents. X squared means x times x, 2 times. So I have used every factor in the first, then move on to the second one here. Look for the new factor. 3 is used already, not new. 7 is new, so times 7. X is used already, so no more new factors. I have used every single factor already. Stop here and write this down. So 3 times 5 times 7 equals what? equals 105 times x squared. So this will be the least common multiple. Having this in mind here, we go back to the original problem. So this one here equals what? I have 2 over 15x. Now we have to compare. How can I turn 15x into 105x squared? How? We have to multiply by something. What should we multiply? Just do the division. If we divide 105x squared by 15x, what the quotient is, then just multiply this quotient. So 15 times 7 turn into 105. X times another x, we'll get x squared. So 7x is missing here. We make this up. Whatever we do to the denominator, do the same thing to the numerator. Okay, see, I have changed the first rational expression. And then this, don't forget this minus. What we have originally 21x squared. How can I turn 21x squared into 105x squared? I have to multiply by 5. Whatever I do to the denominator, do the same thing to the numerator, times 5 again. So now we'll have this equals 105x squared 14x minus what? 105x squared 20. Okay, for this subtraction, they have the same denominators already. Keep the common denominator, 105x squared, and then subtract the numerators, 14x minus 20. Okay, so if this is a test on my open math, you can leave the answer here. Final answer, 100% correct. Okay, the credits will be earned completely. But for this multiple choice here, let's see, when I go through, no A, B does not look the same, C not same, D, only the B here. Okay, so look at what the difference between B and our answer here. So this B actually is a factored form of the numerator. So 14x minus 20. Can we continue to factor this? Because we want to simplify this rational expression. What need we do? We have to simplify. So simplify means we factor the numerator and denominator respectively. The numerator, we can factor the 2 out at 7x minus 10 over 105x squared. So after we tried, we found even though after we factor the denominator and numerator, there is still nothing in common. So we can stop here. So this is what we have as the B answer here. So now for this multiple choice problem, B is the right answer. So on my open math, what I want to tell you, both of those two answers will be correct. You can either stop here or you can stop here. Both. So if we have a problem on my open math like this, both of those two answers are correct. Okay, so now we have done multiplication, division, addition, subtraction. The next topic is the complex rational expression, which means we have rational within rational. Within the numerator and denominator, we still have new rational expressions. This is called the complex rational expression. How do we simplify complex rational expression? We want to get rid of all the denominator within the numerators and denominator respectively. How? Multiply every term by the least common multiple. See, we are still using the LCM or LCD. So when we look at this problem here, we'll see how many denominators are there in the numerator. Just check the numerator. We see just one. Write this down. So there is one denominator y here. Then check the bottom. Do we see any denominator within the denominator? I see another y. So y and y, there are two denominators. What is their LCD? That's y itself. Okay, having this in our mind here, go back to the problem. I'm going to multiply every term by the LCD. So equals, draw this number here. So 4 times y, this term times y, plus the second term times y as well. And go to the bottom here, we have 2 times y plus 2 over y times y. And every single term multiplied by the LCD and then simplify. 4y is 4y. So when we multiply 4 over y times y, we'll see those two cancel out. This y is on the top, this y is on the bottom. So those two cancel each other. I have 4 only. And on the bottom, we have 2y here. And again, those two cancel out. I have 2y plus 2. Okay, after we multiplied every single term by the LCD, we got a brand new rational expression. This is a regular rational expression. Are we supposed to stop here? No, we have to continue to simplify this. How do we simplify this rational expression? Factor the numerator and denominator respectively. The numerator can be factored as 4 times y plus 1. The denominator can be factored as 2 times y plus 1. So y plus 1 cancel each other. 4 divided by 2, that is 2. So the final answer is not 4 over 2, that should be 2. This is a complex rational expression. Okay, and the next one is again a complex rational expression, but this one is a little bit special. It is actually a single rational over another single rational. So we do not have multiple terms in the numerator or denominator. To simplify this special type of complex rational expression, we might don't have to look for the LCD. We treat this one as one division problem. So I can rewrite this complex rational as what? As y over 3 divided by 4 over y plus 5. To rewrite this complex rational as a division here, numerator divided by the denominator. Then we can just do the division. How do we do the division? Turn the division into multiplication by flipping the second expression over, y plus 5 over 4. And then just multiply. Multiply the denominators, 3 times 4. Okay, skip one step, I write down the 12. And the numerator 1 times numerator 2. So y times y plus 5 over 3 times 4, which is 12. See, we see the answer right here. D is right answer. This is a special type of complex rational expression. Okay, here. And if we have a regular complex, then we have to multiply every single one by what? By the LCD. Okay, that's number 12. Starting from number 13 till the last one, we will be working on what? The rational equations. We want to solve for the only unknown in the equation. So look at what we have here. We have W. This is the only unknown. We have the equation here. The equal sign means this is one equation. Solve for what? Solve for W. Okay, the general rule to solve any rational equation is very, very similar to simplify the complex rational expression. We still don't want to work with the denominator. We want to get rid of all the denominators. How? Just multiply everyone, whatever, every single term by the least common denominator, by their LCD. See, I have 3 denominators. Write them down. 4, 12, and W. And I want to ask myself, what is their LCD? So 4, 12, their least common multiple is 12. There is W here, so the LCD, this easy one, is 12 times W. Okay, having this in our mind here, we go back to the original equation here. Spread the terms and multiply every term by the LCD. So I have 4/3 times 12W plus 5 over 12 times 12W equals 1 over W times 12W. See, this, and this. That's the original equation. And I multiply every single one of them by what? By the LCD. That's the LCD here. After we multiply them, so just simplify each multiplication. So when we multiply a fraction by a polynomial, what do? We just can do the cancellation, the division. 12 divided by 4, that's 3. We have W here, so 3W times 1, 3W. And plus 12, 12 cancel out. I have the W left, W times 5, 5W equals what? Equals W cancel out. 12 is left. Okay, see, after we multiply every single term by the LCD, we have get rid of all of the denominators. We have removed all of them. They're all gone. We have a regular, this turns into a linear equation. 3W plus 5W, that's 8W. 8W equals 12. What is W? W equals 12 over 8. And again, for this fraction number, we cannot leave this at this. We have to simplify this. Both 12 and 8 can be divided by 4. So we have 3 over 2, 3 halves. C is the right answer. Okay, when we have the rational expression, we have to make sure we check the answer. How do we check? We just check, does any of our answer or solution make the denominator to be 0 or not? So apparently this one, W is not 0. That's a safe answer. So that's final answer here. Okay, that's regular rational equation. But again, there are some special rational equations, like what we see here. So how special this equation is? We have a rational equation, and there are two rational expressions, one on each side. This turns into a proportion because those two ratios are the same. So for all those special type of rational equation, we do not have to look for their LCD. We just do the simply make the cross product be the same. Cross multiply x plus 1 times x plus 2. Do the diagonal multiplication equal the other cross product, 3 times x plus 9. So by doing this, we can avoid looking for the LCD. So simplify the process here. So do the cross multiplication. And now what do? Just remove all the parentheses. See, what do we have now? X FOIL rule. Multiply those two binomial. I get x squared plus 2x plus 1x. Combine them. 3x. 1 times 2, that's 2. Okay, quickly multiply those two binomial. Equals, for this one, we use the distributive law, 3x plus 27. Apparently, this turns into what? This turns into a rational equation here. Okay, I have x squared term, and then move everything together. X squared plus 3x plus 2 minus 3x minus 27 equals 0. Okay, to solve any quadratic equation, we want to see 0 on the right. See, we move this one to the left, turn this into negative 3x. 27 is moved to the left, turn into negative 27. Then combine like terms. 3x minus 3x, those two are canceled. x squared 2 minus 27 minus 25 equals 0. To solve a quadratic equation, when the right side is 0, what do? We just need to factor the left side. How do we factor this? X plus 5 times x minus 5 equals 0. This is what we did in chapter 6. To solve a quadratic equation, we make the right side of the equation be 0, then factor the left side. It turns into a product to be 0. Then let each factor be 0. Either x plus 5 be 0 or x minus 5 be 0. When we have x plus 5 be 0, what x is? X equals negative 5 or x equals positive 5. So there are two answers. So quickly check. Does any one of them make the denominator here be 0? No, neither one. So that means there are two answers, 5 and negative 5. So B is the right answer here. Special rational equation. And if we have one rational expression on each side, we just cross multiply. One more here for this one. See, this equation, I see, well, I see two terms. I see 0 here, and there are two ways. One way, look for the LCD and multiply everyone by LCD, or I notice for this one, I can move one term to the right. It turns into 1 over W equals W over 4, because that's 0. 0 plus anything still equal that one. So plus W over 4 on both sides. Now we have the special rational equation, cross multiply. W times W. W squared equals 1 times 4, 4. Okay, and alert. When we have this problem here, many students will say, oh, I know. Some number squared equals 4. That number must be 2. Okay, so there's a very common mistake. If you see W equals 2, that will be wrong. Why? Because another number is missed. Okay, so W can also be negative 2. To avoid this mistake, we always follow the general routine to solve any quadratic equation. I just move everything to the left. I have W squared minus 4 equals 0. We want to have 0 on the right. So then we move everything to the same side. Then factor the left side. When we do the factorization, you know, oh, I either get W plus 2 and W minus 2 equals 0. They either factor be 0, you will never miss any answer here. So W equals negative 2 or W equals positive 2. And quickly check, both of the two answers are safe. We will not make W, this denominator be 0. So the final answer will be C, positive or negative 2. Okay, a very, very common mistake. When we see some number square equals another number, we think of the number right away, but don't forget a square of a negative number, still positive. So number 15 is also, so this is a special type of equation. We can turn this into two rational expressions on each side, then cross multiply. 15 and 16 is the same thing here. So to save time, you'll see 16 is another one. How do we solve this? Look for the LCD, multiply everyone by the LCD. The 17 here cross multiply. So they're kind of repeating. To save time, I'm not doing this in front of you. You can, if you want, you can do the practice by yourself. Okay, and also like 18 here, what do we do? Cross multiply. What I want to share with you, the last two problems on the test are what? Are a word problem, a practice problem, a real life problem. We do not see the equations. We have to look for the equation by ourselves. Okay, so for what we do next, let's quickly go over the typical problem that we see in chapter 7, a word problem. Many students, they are afraid of the word problem. And so don't panic when we see the word problem. Take your time and try to figure out what information that we are given and what we are asked to solve. They're very, very typical. For example, the problem we see here is a very typical problem we see in chapter 7. So this one, see, read the problem. Webb can tile a kitchen in 11 hours. So tile a kitchen is one job. And if this job is done by one person, the person name his name is Webb, it will take him 11 hours to finish the job. And it takes Lauren, there comes another person. It takes Lauren 8 hours to do the same size area. So for the same job, Lauren uses a different amount of time. Okay, then if they work together, how long will job be done? And we have used our common sense. If this job is done by two persons together, we got to use less time. Okay, the final answer got to be less than 11 hours and 8 hours. If you, for somehow you get the answer like 15 hours, use your common sense, you know something must be wrong. How do we solve this typical, we call this job or work problem? So always we have one job and one person will use one amount of time and the other person work individually use another amount of time. If they work together, how much time is used? So to work on this problem, we always do this. First, assign a letter to the question. How long will the job take if they work together? I don't know. I make if they work X hours together, they'll finish the job. Okay, now for Webb, so totally he used 11 hours. So then we know to finish the job 1 hour. So this is the amount we call this rate. So the work done by Webb per hour, he will finish 1/11th of the entire job. And for Lauren here, Lauren used 8 hours to finish job. So 1 hour, she will finish 1/8, 1/8 of the entire job. Okay, so there's the rate. Now, both of them, that's the time. Both of them will work X hours. So not only Webb works X hours, Lauren will work with the same amount of time, also X hours. See, Webb each hour, he finishes 1/11th of the job. He works X hours. How much work done by Webb? This person. So 1 hour, 1/11. And he works X hours. So the total job done by him will be 1/11 times X. And the job done by Lauren will also be so 1 hour, 1/8. She works X hours times X. When those two person works X hours, what happens? The entire job is done. So that means this the job done by Webb plus the job done by Lauren. Finish equals the entire job. We let the entire job be 1. That's why for Webb, each hour he finished 1/11. So this one represents the entire job. And then we can rewrite the equation in the horizontal form here. Got 1/11 times x plus 1/8 times x equals what? Equals 1. What do we see here? This is a typical rational equation here. How do we solve this equation? Look for the LCD of all the denominators. 11 and 8, that will be, the least common multiple will be 88, 11 times 8. So multiply everyone by 88, this one times 88 times 88 times 88, and we'll have 88 divided by 11, that's it's 8x plus, those two cancel out, we got 11. 11x equals 88. So we got 19x equals 88. What is x? Solve the x divided by 19, 88 divided by 19. Final answer. Okay, and for this, but when we check the answer, okay, we notice the final answer is in the mixed, uh, we call this mixed form. Okay, mixed format of this we call this mixed fraction, mixed fraction here. So 88 divided by 19, this equals 4. So 88 divided by 76 and 12 over 19. So turn this into a mixed notation. 88 over 19 equals 4 and 12 over 19 hours. And D is the right answer. All problems are like this. So what we do here, we just assume the entire job is 1. Then find the rate of each person. Rate times total time. That's the work done by each one. Then when all the work done, that means the sum of the work done by each person equals what? We got this rational equation here. And another example here. So follow this. Vanessa can take the leaves in their yard, whatever the job, in 6 hours. And Troy can do the job in 7 hours. How long does it take them to do the job if they work together? We don't know, X hours, okay? And then for Vanessa, 1 hour, she does 1 over 6, and she works X hours. For Troy, he used 7 hours. So 1 hour, he works 1/7. And also times X equals 1. See, after we get familiar with this format of equation, we can write down the equation quickly. Solve this equation times 47. We got 7x plus 6x equals, 42. 6 times 7 is their least common multiple. And solve this equation, 13x equals 42. And what is x? X equals 42 over 13. See, C is the right answer. Okay, this is a very, very typical word problem, and you definitely will see a similar problem on the real test, the work problem. There is one more. We call this proportion problem. Okay, what's the proportion? And for example, if we have 2 triangles, and they have the similar shape, but the different dimensions, different size. And we call those triangles are similar. For similar triangles, not only any figures, when they are similar, the corresponding sides are proportional. So what I know, in the smaller triangle, I know this side is 2, this side is 3. And for the bigger triangle, I know this side is 5, and I don't know the other side. So I want to know, and if the 2 triangles are similar, I want to know one side of the bigger triangle, how long that is. So for those, probably call this proportional problem. The corresponding sides are proportional. Proportional means what? The ratio are the same. So 3 and 5, what the ratio? 3 over 5. And what the other ratio? 2 and x are corresponding sides. And that's their ratio. Those 2 ratios are the same. So put the 2 ratios are the same. What do we have now? Now we have one rational equation. How do we solve it? Cross multiply. 3 times x equals 2 times 5, 10. Then we can solve this equation. X equals 10 over 3rd. Final answer. So this is like a geometric problem. In our daily problem, we might also see, like when we take medicine, the amount taken by adults and the children are not the same. So, but based on the weight. So if we know one adult person need to take one specified amount of medicine, and then based on the ratio, how much medicine should be taken by the children if we know their weight. Again, the ratio should be the same. What the ratio? The amount of medicine over the weight For the adult and for the children should be the same. We can write down the equation. So this is another typical proportion problem. All right, so that's all I want to share with you today. This is a quick review, and let me give you a quick recommendation. Don't rush when you take the exam. Be patient. Those 20 problems will take you a good amount of time. I give you 2 hours to finish the exam. I noticed for the first one, I also gave you 2 hours, but many of you just use 30 minutes. Okay, or 40 for this one. Get yourself a good amount of money, the time, at least 1 hour. Okay, don't be too greedy. You want to finish this within 30 minutes. That will be a little bit too challenging. Okay, take your time and work on each problem step by step. Do not skip steps. I'm pretty sure you can get a nice grade. Okay, so that's all for today. And let me stop recording.